Hello everyone, this is Medical Gateway, and today we're going to study a very important topic, which is control systems of the body. So there are two types of control systems in the body. One is the feedback system and the other one is the feed forward system. In feedback system, we have two types. One is the negative feedback system and the other one is the positive feedback system. Now, what exactly is negative feedback system? Negative feedback system is a regulatory mechanism in which the output of a system counteracts or opposes a change in the input, helping to maintain stability and homeostasis. Now, what exactly is happening? It is basically, if there is an input, the output is going against the input in order to maintain a balance. For example, if we see temperature controlling system of body or thermoregulatory system of the body, now if you are in a hot environment, your body temperature goes up, which results into sweating, and sweating tries to bring down the temperature. So the main stimulus was increase in body temperature, and the body is responding to it by decreasing that increase in body temperature or by counteracting or opposing the increase in body temperature. So this is a negative feedback system. Okay. The other example is when there is increased in carbon dioxide in the body, there is hyperventilation, there is increase in rate and depths of respiration, which results into exhaling out of carbon dioxide from the body. So the stimulus was increase in carbon dioxide. What body did? Body did maintain the balance by decreasing the carbon dioxide level by hyperventilation. The lungs exhale the carbon dioxide out of the body. So this is a negative feedback system. So first chapter of Guyton is basically regarding homeostasis, and homeostasis is maintenance of a balanced state in the body. So these feedbacks and feed-forward systems maintain a balance. So first of all, we're discussing the negative feedback system, okay, where the output is opposing a change in the input. So output, decrease in body temperature, is opposing the change, which is increase in body temperature. So they always go in different directions, maintaining the balance. Okay. So there is a key concept when we discuss negative feedback, that is gain of a system, gain of a negative feedback system. So what exactly is gain? Gain is degree of effectiveness to maintain a constant conditions. Now, gain of a system is, for instance, this is thermoregulatory system, which increases or decreases the body temperature by sweating, or in cold environment by shivering. So how effective this system is? If the system is bringing down, for instance, body temperature is raised by 2 degrees Fahrenheit or 2 degrees Celsius, and the thermoregulatory system is bringing back the temperature to normal, then it means the gain is extremely high. Okay. And for instance, if the body is unable to bring back the temperature to normal, then it means the gain is very low. So this is the degree of effectiveness to maintain a constant condition. Now in Guyton, the gain is explained by a formula, which is gain is equal to correction over error. Now, what exactly is correction and what is error? So correction is the improvement done and the error is the improvement not done. Okay. Now I'll explain it with the example of, again, the thermoregulatory system. For instance, the normal body temperature is 98.6 Fahrenheit. Okay, and due to some reason, if the body temperature is raised, for instance, body temperature is raised to 99 Fahrenheit, for example, because of the hot environment. Okay, so now what happens exactly? If there is hot environment and that hot environment is trying to raise the body temperature, what happens? The sweating mechanisms start. Okay, the thermoregulatory system is activated and the sweating starts. Now this sweating will try to bring that down this 99 Fahrenheit temperature back to 98.6 or as near as possible to 98.6. Now, as an example, to explain the gain of a system, for example, sweating starts and the temperature is decreased to 98.7. Not 98.6, the temperature is decreased from 99 to 98.7. Now, actually, I'm going to explain you what exactly is correction and what exactly is error. Now, correction in temperature after sweating is basically the temperature is decreased from 99 to 98.7. So the correction in temperature after sweating is 99 minus 98.7. That is 0.3 degree Fahrenheit. Okay, so 0.3 degree Fahrenheit is the correction in this case. Now, what exactly is error? Error in the temperature still left after sweating. Now, the thermoregulatory system has played its part, sweating is it started, but still some of the temperature is not being regulated. For instance, the temperature wasn't decreased from 99 to 98.6, it was decreased to 98.7. So what's left behind? That is error. So error is 98.7 minus 98.6. The error left by the thermoregulatory system. So in this case, the error is 0.1 Fahrenheit. So it is the amount of the correction done, and error is the amount of the correction not done. Okay, so this is the correction in this case is 0.3 Fahrenheit, and error, which is still left behind, that is 0.1 Fahrenheit. So what exactly is gain? Gain is correction divided by error. If the value of correction goes up, the gain is high. If the error goes up, the gain is low. So the correction in this case is 0.3 and error is 0.1. So the gain of the thermoregulatory system in this example, according to this example, is 3. For instance, if the correction is 0.35, then the error would be 0.05, then it would have been much greater than 3. Okay, now I have just given this example to explain this. The gain of the thermoregulatory system is extremely high. That is not 3. I've just given this example to explain it. That is extremely high. I'll discuss it in the next slide. Okay, so coming back to the gain and the main slide. Okay, so if we compare in Guyton, there's two systems, baroreceptor system and the temperature control system. If we compare them both, baroreceptor system is the system which controls the blood pressure. For instance, your normal blood pressure is 120 by 80. 120 is systolic blood pressure. If the systolic blood pressure goes from 120 to 160 millimeter of mercury, then the body will try to bring it down back to 120. But the body is unable to bring it down back to 120. It will bring it closer to 120. No feedback system is 100%, but some feedback systems have huge gain and some has less gain. So what do you think? Which system, baroreceptor system or temperature control system, which has the greater gain? So the temperature control system works extremely effectively. It has extremely high gain. So the gain of the temperature control system is 33. In the last example I've shown you in the previous slide, I have shown the gain of 3. That was just as an example. In real time, the temperature controlling system, the thermoregulatory system of the body is extremely fine, and it has a huge gain, which is 33. Okay. So now what exactly is, so this was negative feedback. Now what exactly is positive feedback? Now positive feedback is a regulatory mechanism in which output or response of a system amplifies or reinforces the initial stimulus, leading to an increase in the original disturbance. Now basically what is happening, that the output is supporting the initial stimulus. In the case of negative feedback, the output was going against the initial stimulus, but in the case of positive feedback, the output is amplifying the initial stimulus. For instance, if I take the example of thermoregulatory system, and if the thermoregulatory system behaves like a positive feedback system, then this example turns out to be like, for instance, if the body temperature is increasing and the thermoregulatory system starts shivering of the body. Now, shivering produces a lot of heat, and that heat will further increase the temperature rather than decreasing it. So then that would have been a case of positive feedback system. Okay, but that is not the case. I'll just discuss the examples of positive feedback. So in positive feedback, whatever is the initial stimulus, the output amplifies or supports or reinforces the initial stimulus, and it will be a loop of like a vicious cycle. It will just keep on increasing and increasing and increasing. Okay, now, so we can say that the negative feedback system is basically more related to the balance, but a positive feedback is, superficially if we discuss it, is not related to the balance. Okay, now let's discuss examples, and then we'll discuss whether it is related to balance or not. Okay, now, so first example is blood vessels. For instance, if a blood vessel is ruptured, now what happens? That the clotting enzymes are activated. Now, whenever there is activation of clotting enzyme, it will lead to more activation of the other clotting enzymes. And the other clotting enzymes will further increase more clotting enzymes activation. So it will behave like a loop of positive vicious cycle, that one thing is promoting the other one, and the other one is promoting the other one, and it just keeps going on and on and on. So blood vessel rupture, clotting enzyme is activated. That clotting enzyme activates the other enzyme, and the other enzyme then activates another enzyme, and they all keep on activating each other. So this is a typical example of a positive feedback system. Now it looks like that it is a bad thing, things going in one direction and not maintaining a balance, but positive feedbacks are also a part of some bigger negative feedback. How exactly is this? Okay, now, when the blood vessel is ruptured, basically we want to maintain the balance by stopping the bleeding. So this positive feedback is basically stopping the bleeding, and stoppage of bleeding itself is maintaining balance. Okay, so the next example is childbirth. During the childbirth, there are uterine contractions, and whenever the uterus there is contraction of the uterus, the baby's head moves forward towards the cervix, and it stimulates the cervix. And whenever there is stimulation of the cervix sends impulses back to the uterus for further more contractions. So uterine contraction leads to baby moving forward and stimulating cervix, and stimulation of cervix is again causing a uterine contraction. So uterine contraction, stimulation of cervix, and then cervix leading to further uterine contractions. Further uterine contractions, more movement of head forward, more stimulation of cervix, and more uterine contractions. So this is a positive feedback cycle which results into delivery of the baby. Okay. Now the third example of the positive feedback system is during the action potential. Now, what happens in action potential? The positive ions move inside. The sodium ion moves inside. And whenever there is movement of positive ions inside, there is electropositivity inside the cell. And whenever there is electropositivity inside the cell, this results into more opening of sodium channels. And sodium channels, when the sodium channels open, this results into more sodium movement inside. Now this is again a positive cycle. Okay, the first step of the action potential is the sodium ions move inside. Now, sodium ions move inside from sodium channels, but the movement of sodium ion inside, or whenever there is electropositivity inside, it results into more opening of sodium channels and more opening of sodium channels, leading to more sodium movement inside, creating more electropositivity. So this is the cycle. Okay, so these are very important 3 examples of positive feedback system. Now we're going to discuss the feed forward system. Feed forward system. Now this is interesting. Feed forward system is also known as adaptive control or delayed negative feedback. Okay, now what is the basic difference between feed forward system and feedback system? Now, in feedback system, there is a stimulus and the body is responding to that stimulus. After the stimulus has occurred, there is increase in temperature, there is increase in carbon dioxide, there is action potential, there is rupture of blood vessels. So in feedback system, the stimulus comes first, and then the body responds to it negatively or positively, to maintain balance. Whereas in feed forward system, the stimulus hasn't occurred yet, and the body has already given a response as a preparatory response for the stimulus, which hasn't occurred yet, but which is going to occur. In feedback system, the stimulus has occurred and then the body responds. In feed forward system, the body has already responded to a stimulus which hasn't occurred yet, but the stimulus is going to occur. Okay? For instance, again, I'll give the example of the thermoregulatory system. For instance, if the thermoregulatory system behaves in a way that the person starts sweating before the rise in body temperature, then that would be an example of a feed-forward system. For instance, if the person is sitting in an air-conditioned room where the temperature is perfectly fine, the person is not sweating, but the person is going to move out from that cold environment into the hot environment outside the room where there is scorching heat, and the person hasn't moved out of the room, but the sweating starts before moving out of the room as a preparatory mechanism that the person is going to move out of the room, then that would have been an example of feed-forward system. Okay, but this doesn't, in the thermoregulatory system, it doesn't behave like as feed-forward system, it behaves as a negative feedback system. I just gave this example to explain. Now, what example is given in Guyton of adaptive control? The example is of the body movements. For instance, if a person is running and he or she is going to take a turn towards left, okay? Now what happens that before the person is going to take a turn to the left while running, the body is tilted towards right side before the turn is there. The body is tilted towards the right side in order to maintain the balance and preventing the person from falling. So these rapidly occurring body movements are an example of adaptive control. Now what happens that brain sends feed-forward signals to the muscles for the upcoming movement. The movement hasn't occurred yet, the turn hasn't arrived yet, the change hasn't arrived yet, but it's going to occur. So the brain is sending feed-forward signals to muscles for the upcoming movement. But how the body knows that I have to turn to the right before the movement? The body has learned this from some previously occurred movement by learning from the previously incorrectly performed movement. Okay, so that's why this is known as the delayed negative feedback. Feed forward is also a negative feedback but this is a delayed response of the negative feedback. Okay? So this example is given Guyton. One more example is given. For instance, if you are going to eat food, but before the food enters in your mouth, there is production of saliva. So the food hasn't entered your mouth or your body, but the saliva is already being produced. So there isn't any change, there isn't any stimulus, but the saliva is produced. But that is a debatable example, because one can say there is a stimulus because someone has seen the food there, or the smell of the food has resulted in the production of the saliva. Okay? But still, the saliva is there for the food, to digest the food or to make it more lubricated. But it hasn't entered the mouth yet. So, but in Guyton, the only example is, if in exams you're asked, you have to quote the examples of the upcoming movement. So this is the control system of the body, the feedback system and the feed-forward system, the negative feedback and the positive feedback system. Okay, so by this we have completed chapter 1 of Guyton. See you in next chapter.